Okay, welcome back everybody. Today we're going to continue on with practicing and applying the cosine law to various situations, while at the same time we're also going to be practicing creating diagrams from worded situations. So you're going to be practicing a lot today. So let's get started with these few examples here. So here we have a race that follows a triangular course. So all that means is you're going to put 3 dots in a triangle. Don't assume anything about the triangle, such as that there's a 90-degree angle anywhere in it. So just make a basic triangle. The legs, so each of these lines is considered a leg, right? So basically a portion of the race. The 3 portions of the race are in order. So whichever one you want to consider to go first, you're going to write 2.3 kilometers on it. So I'll just decide to put that up there. Then a 5.9 kilometers. And then a 6.2 kilometers. Find the angle between the start, so the starting and finishing legs. So it says in order. So the 2.3 kilometers was the first part. So this is the first part, the second part, the third part. So if this is the start, and then this would be the first leg. So first leg, second leg, third leg. So you're going to start here. So that's why I called it S for me. You're going to go here, and it said find the angle between the starting and finishing legs to the nearest degree. So the start and the finishing leg. So this is the starting leg. That's what this means. So starting leg. This guy is the last or the finishing leg. Okay, so what it wants is the angle between them. It wants that guy. It wants angle S. So that's what we need to do. We need to find angle S. So let's go through what situation we actually have here. So pretend that you don't know it's supposed to be cosine law. It's just some random question. So you go through the diagram, you're like, do I have a 90-degree angle? Well, I don't know. I don't see one, so I can't assume that there's one. So that means I can't use SOHCAHTOA. So that's out the window. Do I have an angle and side combo where I know both the angle and its matching side? Well, I know this side, but not this angle. I know this side, but not that angle. And I know this side, but not that angle. So obviously, because it is a side, side, side situation, so this is my thinking out loud. You don't have to write this down, obviously. This is what leads us into using cosine law. So cosine law is the last case, right? Your last resort. Now, in this case, though, I know all 3 sides, so it's an angle that I'm missing. So I'm going to set up cosine law so that angle S is in the formula, because that's what I'm going to try and solve for. So if I want angle S, capital S, to be in the formula, that means I need to start with little s. So the way this formula would look for me, based on my SAB letters, S squared equals A squared plus B squared. So again, this is little a, this is little b, right? A squared plus B squared minus 2AB times, again, you don't have to put the times symbol if you don't want, cos angle S. So that's why I had to start with angle S, because I wanted to have angle S in it in order for me to be able to solve for this. Now, if you memorized how to get this isolated right away, then obviously you don't need to start with this. But again, I'm going to show you that all we do is kick this guy out to the other side, he becomes subtract. Kick this guy out to the other side, he becomes subtract. And then divide by this chunk, negative 2AB. And this is what cos angle S equals. So if you memorize this, then by all means just start here. But again, I'm just showing people where it comes from. So now I can insert my numbers. I'm going to leave off the kilometers. So little s is 5.9. That's going to be squared. And then I'm going to minus 6.2 squared. You can put the brackets or not. It doesn't really matter. 2.3 squared all over negative 2 times these two same numbers again, 6.2 and 2.3. And that's what cos angle S is going to equal. So have to figure out the top. So again, make sure you are in degrees mode before you always start. 5.9 squared minus 6.2 squared minus 2.3 squared. And we get negative 8.92. Again, no rounding because we're not done yet. On the bottom, negative 2 times 6.2 times 2.3. Negative 28.52. Now, keeping in mind that when I divide this by this, I'm going to get a 0 point number. So another decimal. I don't want to be bothered to write that down. So before I do that, I'm also going to kick out the cos to the other side and just save myself some time and just write it all together at once, leaving me with just angle S on the other side. So now I can go right away, type in this number, divide it by that number, and then go second or inverse cos. So 8.92 divided by 28.52, and I left out the negatives because I know a negative divided by negative is a positive anyway. This is the 0.312 number. I'm not going to bother to write that down myself. Inverse cos gives me 71.8 degrees to the nearest degree. So 71.77 is what my calculator said, but I'm going to respond back in words. Therefore, the angle between the starting and finishing legs so starting and finishing legs is, and then you read what does it want? Nearest degree, 71.77 becomes 72 degrees. Right? No decimal places. And we are done. It didn't ask us for any of the others, so we can move on. All right, John rides his bike. John rides his bike due east. So again, this is assuming that you know your north, south, east, west. So north, south, and then W-E, right? Spells we. So when it says due east, it means like that. That's due east. So straight east. That's due east. For 10 kilometers, Angela rides her bike east, tilt 25 degrees south. So east, 25 degrees south. So you head east first, but then you tilt 25 degrees south, that angle in there, for 7 kilometers. Okay. So what this is saying is John and Angela start at the same spot. That's what it says. So this is their start. John is going to ride straight to the right. So this is John. He did that for 10 kilometers. Okay, so he finished there, say. Angela rides her bike east, tilt 25 degrees south. So you start at the first direction, and then you go the amount of degrees towards either east or south. In this, either north or south. In this case, south. So down here, say, and east 25 degrees for 7 kilometers. And this, what's her name? Angela. How far apart are they to the nearest 10th? So we're trying to figure out the distance between John and Angela after they rode off in their different directions. So let's go through our situation here. Do I see a 90-degree angle? Now, the way I drew mine, it looks like that could be 90 degrees, but that's just my fault for drawing it that specific way. So ignore that that looks like 90 degrees. If you don't know that it's 90 degrees for sure, then ignore that. So that means we can't use SOHCAHTOA. I don't have an angle side combo. I have this angle, but I don't know that side. I have this side, but I don't know that angle. And I have this side, but I don't know that angle. So because I don't have enough information to do sine law, it can't be sine law. So this is the side angle side situation, SAS, which means it's cosine law. So again, that's my analysis that I do in my head. Now I'm looking for, in this case, little s, right? Opposite vertex s. That's the distance between these two people. This is little j, and this is little a, based on my letters. If you did ABC, then of course you use ABC. So I'm going to set up cosine law, and the only thing I can find is the angle across the side across the angle that I know, which is good because that's what I'm looking for. S squared equals a squared plus j squared minus 2, those same two letters, aj cos capital S. You can put the angle sign or not, doesn't matter. S squared equals little a is 10, j is 7, of course drop the kilometers, minus 2 times 10 times 7 times cosine of 25 degrees. So now we're going to enter everything, starting at the back, moving forward. So you're going to enter cos 25 degrees first, times 7 equals cos 25 degrees times 7 equals times 10 equals times negative 2. So times negative 2. Some of you do the 2 first, then the negative. So you should now be at negative 126.88. This is the whole back answer. All of that is multiplication. So according to order of operations, this has to be done first. Then we add 7 squared. So pretend you don't know it's 49. You can just go plus 7 squared. And then we add 10 squared. Now again, pretend you don't know it's 100. You could just go 10 with the square on it, or after the plus sign bracket, 10 times 10, close bracket. Either way, after you press equals, you get this 22.11690982 number. Now, keeping in mind that that's not how far apart they are. That's s squared. So just like Pythagorean theorem, to get the actual side length, while it's all still in your calculator, square root it. And you get a 4.7 answer. Now to the nearest tenth of a kilometer. So there we go. So therefore, John and Angela are 4.7 kilometers apart after they ride separately. So that's this distance here. All right, let's move on to the next one. So okay. Hopefully that noise won't bother us. What do we have here? Two boats. Two boats left a harbor at the same time. Let's see if I can fix that. Okay. Hopefully that's good enough. So we got two boats. It's kind of like the one we just finished. Two people on a bike. Two boats left the harbor. So the harbor is a common location. So they branch out of the harbor at the same time. One traveled 10 kilometers an hour on a course of north, tilt 47 degrees west. Okay, so again, this is assuming that you understand north, south, east, west. North, south, west, east. So you're going to head north, and then you're going to tilt 47 degrees west. The other traveled from the same location at 8 kilometers an hour on a course of north, 79 degrees west. How far apart are they after 2 hours? There, you got to read that part. 2 hours. All right. So, harbor. I'm going to do a big diagram. H for harbor. I'll just do dotted so it's not, doesn't confuse you. There's west, there's north. Okay, so out of the harbor, first guy travels north, tilt 47 degrees west. So go north first, and then tilt 47 degrees west. So he'll be more like this. So that's boat 1. So I'm going to call him A. So that 47 degrees is this part. right? Because he first went north, then he tilted 47 degrees towards west. The other traveled 8 kilometers an hour on a course of north 79. Now 79 is more than 47, so he's going to be closer to west. So he's going to be more like that. And I'm going to call him boat B. So the whole thing, he started north and he tilted 79 degrees. So the whole thing is 79. How far apart are they? So that's the part we don't know. To 1 decimal place after 2 hours. So the reason why that 2 hours is important, if you travel 10 kilometers per hour, that is in 1 hour, right? That's for 1 hour. So 1 hour later, you've gone 10 kilometers. For 2 hours, we obviously have to times it by 2. And that's what gives us 20 kilometers. So the first guy traveled 20K. The second guy, 8 kilometers per hour. For 2 hours, he should have gone a total of 16 kilometers. So the second guy is a distance of 16 kilometers out. Okay, so that's why that 2 hours part was important. If it was only 1 hour, then we would just use the 10 and the 8. All right, what else do I need here? I need to figure out, because obviously I'm looking for little h, which is great, but I need to figure out this amount of degrees, because it gave me 79 and gave me 47, but notice none of those two numbers are actually inside the triangle. So to get angle H, I have to do the full angle minus out the portion that's outside the triangle right here. So I have to go 79 degrees minus out the 47 degrees. So 79 minus out 47 is 32 degrees. So that's the amount that's actually inside that corner, which is what I want because that's opposite the little h, which is the distance that I'm looking for. So I think I have everything. This is side, angle, side. So this is definitely cosine law. So in my head, I've decided that cosine law is the tool to use. I'm using it to solve for a side. In this case, h is what I'm looking for. So h squared equals a squared plus b squared minus 2 times a times b times cos capital H. Fill in your numbers. Again, the order you write these in doesn't matter. 20 can go first before the 16. Minus 2 times 16 times 20 times cosine of the 32 degrees. That's inside the triangle. Again, you start at the back and you move forward. Cos 32 equals times 20 equals times 16 equals times negative 2 equals. I don't want to bother writing that number down, so I just go plus 20 squared, so 20 times 20 in other words, plus 16 squared. So either way, like I said, brackets with the time symbol or with the square on it. And you get this 113 number. So h squared equals 113.2492185. Again, it's all of that. And then you square root. Notice I didn't clear my calculator. 10.6 because I wanted it to 1 decimal place. So I already know 10.64. We're going to call this 10.6. So how far apart are they? Therefore, the two boats, or ships, boats, are 10.6 kilometers apart after 2 hours. And that answers the question. Okay, so the last thing I want to talk about down here before you do your practice is something called bearings. So up here you were practicing north, south, east, west directions, right? So you always start with whatever the letter it starts at. If it started at south, you would be heading south first, and then you would tilt either the amount of degrees west or east, whatever it finishes with. There's another way of giving direction, and that's called bearings. Okay, so the word bearing is a different system. Again, it's north, south, east, west. But what happens is you're given a 3-digit code, and pilots use this. So what happens is you can be at 0, 0, 0, all the way up to the full circle, which is 360 degrees. So what happens is it's measured clockwise from north. So it's like the 12 o'clock on a clock. So we have north, and what happens is you go a certain amount of degrees. So say 60 degrees. That's a bearing of 60 degrees. I've gone 60 degrees that way, and it's always clockwise. It's always to the right. So if it was, say, 120, that would be a bearing of 120 degrees. Started north. If you were straight flat, that would be 90, right? You would make a proper 90-degree corner, so you went a little beyond that to 120. 180 would be directly on the opposite side. So again, here's north. If I go 180 degrees, I'm directly opposite north. So really, I'm due south. I'm all the way south. And of course, you can go to 200, 210. 270 would be over here, 90 degrees over here, and then you're into the 300s as you get back up to north before you close the circle. So if you see a question with bearings on it, it's just a different way of measuring degrees around a circle. You always start north and then you tilt clockwise that amount of degrees. So this diagram is showing you 135 degrees total. So you went past 90, a little bit extra. Now you know the amount that's just past 90. It's whatever 135 minus out 90 is. In this case, 45 would give you this amount of degrees in there if you needed it in the question. All right, see you next time.